The electronic structure of atoms and molecules in ionic structures is so important to the properties of these substances that it's really critical that we're able to have a way of representing the electronic structure and understanding the electronic structure. Hey everybody, we're going to go over how to draw Lewis structures for chemical substances in a stepwise fashion that makes it pretty straightforward. Step one, we need to know what is the substance that we're working with. Let's say it's water. What is the chemical substance? Step two, what is the formula of this compound? H2O. So this video assumes that you're already comfortable with electron configurations and understanding what valence electrons are and how to determine the number of valence electrons that any element has. Step three, how are these atoms arranged in this compound? We know that there are 2 hydrogens and 1 oxygen, but how are they arranged in the molecule? We need to understand that oxygen is the central atom, and if we're not quite there yet, then you need to know or be told that oxygen is the central atom. So once we know that this is the arrangement of the atoms, we can determine how to distribute the valence electrons throughout the molecule. That brings us to step 4. How many valence electrons are involved in this molecule? We have 2 hydrogen atoms, and we have 1 oxygen atom. Each hydrogen brings 1 valence electron to the party. So we have 2 valence electrons, 1 from each hydrogen. And we all understand that oxygen brings 6 valence electrons to the party. So we have a total of 8 valence electrons to distribute through this molecule to show its electronic structure. Now that we know what substance we're working with, what its formula is, which tells us how many atoms of each element are involved, what the arrangement of those atoms is, how many total valence electrons we have, now we're ready to show how to distribute these valence electrons. I like to think of these valence electrons as a little pile of jelly beans, and we have to distribute the jelly beans throughout the molecule. I'm going to take this arrangement and move it over here. So we see that oxygen is the central atom here, and bonded to it are 2 hydrogen atoms. We have 8 valence electrons to distribute. I'm going to start by putting a pair between the atoms because I know I can assume that there's at least a pair of electrons shared between the hydrogen and the oxygen here and the hydrogen and oxygen here. So that uses up 4 of our jelly beans and leaves us with 4 additional jelly beans in our pile. What I want to do now is check the non-central atoms to be sure that they've satisfied the noble gas configuration. We know the noble gas configuration is the goal for all atoms. So the non-central atoms in this molecule are hydrogen. And I see here that hydrogen, by sharing 2 electrons with the oxygen, has 2 valence electrons, which gives it the same configuration as helium. So there you go, it's got its noble gas configuration. Same with this hydrogen over here, obviously same thing. So then I look to the central atom, and right now I see that it's got 1, 2, 3, 4 valence electrons. I've got 4 electrons left to work with, so I can distribute those around the central atom. My pile of jelly beans is now 0. I've distributed all of the valence electrons into the molecule, and I see that oxygen ends up with 2, 4, 6, 8 valence electrons. It gets the octet just like a neon atom, and that each hydrogen ends up with 2 valence electrons. So effectively, we've shown how each of the atoms in the molecule has achieved the noble gas configuration, which again is the ultimate goal for all atoms. So let's review. How do you draw a Lewis structure for a molecular compound? First, we need to know the formula, so we know how many atoms of each element are involved in the compound. Then we need to know how those atoms are arranged. So we need to know which is the central atom that the other atoms are bonded to. The next thing to determine is the total number of valence electrons, so that we can keep an account of the jelly beans as we distribute them throughout the molecule. Then we take the arrangement of the atoms, the two hydrogens on the outside with oxygen as the central atom, and we distribute first a pair between the atoms to represent what we know is the case, that these atoms are sharing at least a pair of electrons. So 2 there and 2 there. That left us with 4. And then we took those 4 and we made sure that we were satisfying the noble gas configuration for every atom in the molecule. For hydrogen, that's 2 valence electrons. Check? Check. For the oxygen, it needs to have 8. 2, 4, 6, 8. 2 of the pairs here are considered shared pairs or bonding pairs. And 2 of the electron pairs around the oxygen are unshared or unbonded. And that's important in determining other properties of water. So that shows us the electronic structure of the water molecule, which again is so influential to the properties of water and would be the case for any particular compound, where the electronic structure is really determining so much about how this substance will behave. We see the way the valence electrons are distributed. We can identify which of the electrons are involved in bonds and which electrons are not involved in the bonds, because they all play a role in determining so much about the properties of this substance. So there you have it. This is how you would draw a Lewis structure for a molecular compound.